G'day guys. So this is a Sinergex Pure Charge 10. This was in my camper van, the Toyota Hiace camper van. It is a 10 amp 14.4 volt automatic multi-stage battery charger. Now they use this as a solution for the dual battery system. So the dual battery system in the Hiace was really simple. I started undoing it as we say that. This is dead. So I'll explain how the system was working. If I can turn the screws, which I can't, try this end. So the way the system works in the Hiace, there is a sealed lead acid in the back and a normal start battery in the front. I was hoping to use my good little aluminium cool screwdriver, but we need more torque on the screws. Anyhow, there's two batteries in the Hiace, one in the front, start battery, one in the back, the, I guess you'd call it a house battery, which ran 3 different lights, the 12 volt fridge, etc. So the fridge goes over to AC when you plug it in, so the fridge runs on 240. The lights still run on 12 volt. Yeah, everything ran on 12 volt. And all it did was liven up a couple of power points. So this is the little solution that they had. When the shore power gets plugged in, or the main power, whatever you want to call it, as soon as that got plugged in, this was on a power point on that circuit, and it'd start ploughing 10 amps into that back battery. Now, problems with that. 10 amps is about what all the incandescent globes in the back of the thing would use, plus the fridge, no worries. So it was undersized, basically. Struggling from day one. Okay, so what's in this end? We've got an on-off switch. So we should be able to push or split. Okay, so there's a fuse holder. Looks as though we split it and actually push everything through it. Never pulled one of these apart before. And yes, if you noticed that was a flat blade, bonus points for you. So it just has a single LED that normally does all the descriptive work, which tells you that you're either charging fast, floating, or whatever. Let's pull this out and see what we've got going on in here. Okay, so solid enclosure. That side there was the side that the PCB's on. Okay, nice big aluminium heatsink right across the back board. Ugh, yuck. Interesting solder job down that end. Stretch the fan cable there a little bit. And there appears to be sort of fuse on board there. Might be a fuse, so we'll get the continuity check out and just see if the audio check's the best. I like it. We might be in luck. .5 amps at 250 volts is the fuse. Down on the board in there, and that is blown. So we need to desolder that and get a new fuse going on. So that fuse there is the output one, okay. Why'd the fuse blow? Good question. Surge load, too low voltage, something like that. Got some ugly stuff going on in this board. You see that pile of resistors there? They're on top of a blob of silicon and they're just a pile of them. I wonder if I've got a fuse somewhere handy. I can just solder it across the back side of this to see if it'll fire up. I'll see what I can find. Alright, changed my mind a little bit. For the optimum of sketchiness, I'm going to just check and see if it's got voltage on one side. There we go, AC. 239 on that side. Nothing on that side. Okay. That proves exactly what I wanted to know there. No, we can't do amps with that one. That's only a clamp meter. We need a different multimeter. And one's flat. Ah. Find a multimeter. Alright, so the little must tool. Let's see what happens when we bridge the fuse. Yeah, something dead shorted inside of there. That's why the fuse has gone pop. That was definitely a safe-ish way to test that. This tool is charge is dead. As kind of suspected. There was a hell of an arc out of that. What caused it to fail, still not sure. It's all isolated, we'll let that sit there and de-energise. But yeah, that's kind of weird. There's no real corrosion, even though I initially suspected that was what it could have been from the case. There's a lot of corrosion on that side of the case there. From there was a lot of sand in the bus when I bought it. Beach dwelling device. Yeah. So something on the board has gone kaput. It is a well and truly complex PCB for a battery charger. I don't understand why it's so serious. And resistors. But it is rather shittily built. Solder and stuff like that on it. All over the show. So judging by the build quality, I can't recommend them as a good thing. That's now e-waste. Intelligent 3-stage charger. Can't imagine what it would have cost initially. I'll link a simple but smart battery charger in the description for you. Yeah, I don't really rate that. Something you can run constant duty and handle. That used to get it ridiculously hot. There's obviously something wrong with it. I thought I'd open it up and show you inside anyhow. Thanks for watching. Catch you on the next video. Merch link's starting to build up in the description, so we can now sell merch on teespring.com. There'll be a link for that, and that'll be in every video description from now on. Thanks heaps for watching. Catch you on the next vid.